sharing experiences, really important, learning from each other, hearing from our expert speakers.
I want everyone to really take control of their health, because it's your body and your life, and if you're not in control of it, no one else will be.
Turns out that almost all pacemakers are completely fine to go through an MRI scanner.
Both septal ablation and surgical treatment show good results. It's safe, comparable.
HRT for many women is a lifesaver.
However, and it was a real shock, they told me I did need a transplant.
It's funny being a carer. You know, sometimes people don't take their medicines properly and you get cross at them. Why are you not taking your medicines?
I would say the next big stage in the development of this story was our understanding that this is, in many people, a genetic condition. So it's a heritable and transmissible disease.
So some of the pros of genetic testing are that we can find a causative gene change in some people.
Thank you all for being here, and I especially want to thank Cardiomyopathy UK. This is, for me, a first that I get to talk to patients, but I think the direction of research is more and more going towards research priorities need to be a conversation between the researchers and the patients, and so I think this is a great opportunity. So I'm a professor of cardiovascular sciences at KU Leuven, which is a university in Belgium, but I'm here speaking as the coordinator of a research consortium called Crucial. And Crucial is focused on understanding the link between the heart and the brain, and specifically we're studying the role that your blood vessels play in the link between the heart and the brain. So I'm going to start off explaining what this link is and explaining why the heart and the brain are so interconnected, but then go into our approach to this research question, some of our results, and what this means for you guys as patients. So in terms of the heart and the brain, we've known for a long time that there's a link between the heart and the brain. Your heart creates blood flow. Blood flow is, your brain needs blood flow to operate properly. So the harder your heart pumps, the more blood flow you have, the better brain function you have. But it also goes the other way. Your brain controls your autonomic nervous system. Your autonomic nervous system is the part of your brain that you don't think about. It's the part that's without you realizing. Things like your breathing rate, things like digestion, things like, the function of different organs. And so your autonomic nervous system can control the rate at which your heart beats and the strength with which it contracts. And so they link to each other, right? But beyond just that which has been known for a long time, we're also starting to realize that the heart and the brain are especially sensitive to certain conditions. Your heart and your brain are organs that have large metabolic needs. That means both your heart and your brain need a lot of energy to function properly. So if we look here, there's your heart, there's your brain. They're organs that need a lot of energy to function properly. And so they're especially sensitive to any sort of condition that causes the delivery of oxygen or the delivery of nutrients to the tissue to be affected. And so what we're focusing on is the role that the microvasculature has in bringing nutrients properly to these two organs, okay? So your microvasculature is, you have your large blood vessels like your arteries and your veins, but the smallest blood vessels of your body are called your microvasculature. And I think the one that people might have heard of most likely is your capillary blood vessels. They're the tiniest little blood vessels of your body. But your microvasculature actually has different parts. It's got the arterioles that control flow to different organs, the capillaries, and the venules. And so these haven't been studied as much as your large blood vessels because they're harder to get to. But these tiny little blood vessels are the ones where exchange is actually happening, where nutrients actually go into the tissues, where waste comes out of the tissue back into the blood. And so in organs that need so much nutrients and so much oxygen, they're especially sensitive to dysfunction of the microvasculature. And so we're focused on the heart and the brain, and we're specifically focused on diseases that are related to microvascular dysfunction in the heart and the brain. And so these have, in the heart, it's been known that the blood vessels that feed the heart itself, the heart is sensitive to dysfunction of these vessels, of the microvasculature. And in the brain, things like vascular dementia and vascular cognitive impairment are affected. So I wanted to go a little bit more into these two diseases and explain what the role of the microvasculature is in there. So in your heart, there's two ways that your heart can fail. Your heart can fail because it doesn't contract enough. And I think things like dilated cardiomyopathies are more related to contractile function, but that's one way the heart can fail. It's not strong enough to pump enough blood. But the other thing that can happen with your heart is that your heart can become stiff and then it doesn't relax properly. Okay, so heart failure in general is is your heart being unable to produce enough blood flow to meet the needs of your body. And so in diastolic heart failure, the heart isn't relaxing properly, it doesn't fill with as much blood, and so even though the contractile function is normal, not enough blood flow is going to your body to meet its needs. And so if you look at the microvascular dysfunction, it's often more associated with problems of diastole, of relaxation. The heart doesn't relax properly. The heart becomes stiff because the microvasculature isn't properly feeding the heart muscle. And the heart muscle also becomes hypertrophic in this case. And so, so the heart can either not contract properly, and this is generally referred to as heart failure with reduced ejection fraction, or it cannot relax properly, and then it's called heart failure with preserved ejection fraction. It's not better because it's preserved. This is really just about the way that ejection fraction is calculated. When it doesn't relax properly, you don't see it in measuring the ejection fraction. Now, diastolic heart failure arises in people who have what are called metabolic comorbidities. So these are things like hypertension, which is down here, obstructive pulmonary disease, kidney problems, obesity, diabetes. And it's thought that all of these different conditions here cause your microvascular dysfunction, which causes all of the molecular problems that are associated with the heart becoming stiffer. Now, in the brain, we're looking more at what's called vascular cognitive impairment. That's an umbrella term for everything that has to do with cognitive impairment that originates from vascular problems. Okay. Now, in its furthest stage, vascular cognitive impairment is vascular dementia. But we want to include earlier stages before it's dementia when there are more subtle problems. And so we use the term vascular cognitive impairment because it's more of an umbrella term. Now, vascular cognitive impairment is also, it's associated with reduced blood flow to the brain. It's associated with, normally your brain will couple cognitive activity to the amount of blood flow that goes to that region. And if that becomes impaired, that's present in vascular cognitive impairment. But you also have various inflammation and components. Now, the reason we focused on these two diseases is because just like diastolic heart failure, vascular cognitive impairment has the same risk factors. And so chronic obstructive lung disease, hypertension, aging, chronic inflammation, obesity, and diabetes are also causal factors in this vascular cognitive impairment. And actually, in both cases, in diastolic heart failure and in vascular cognitive impairment, the theory is that microvascular dysfunction, the dysfunction to your smallest blood vessels, are what drive disease. Okay. Now, before I go into the research that we have actually done, I wanted to make one important point that a lot of people think of dementia as memory loss. Cognitive impairment is much more than memory loss, okay? Alzheimer's is very much, is memory, is, recognition memory and things like that. But vascular dementia is much more about information processing speeds and executive function, okay? And executive function is in some ways doing two things at once, but doing two things at once can be, walking and talking at the same time. It's not, complex processes necessarily, but executive function is also one of the things that's very much noticed in vascular dementia is following positional, positional information, but following, getting from A to B and knowing where you're going. And people with vascular dementia, even in their own home, will sometimes get to a door to go and be going towards the bathroom and will turn left instead of right, even though it's their home and they've lived there forever. And so this is an example of defects in executive function. Okay. And so, vascular cognitive impairment is something different than just normal aging and memory loss. It's actually visible on MRIs. And so you can ignore, these are just different types of imaging of MRI that are done on the brain. But depending on the way that they do the imaging, they can see things like microbleeds. These are, your blood vessels hemorrhage, and you can have microbleeds in your brain. You can, in this type of imaging, you can see regions that are whiter. It should all be this, your brain should all be this gray color, and these are called white matter hyperintensities. You can also see smaller infarcts in the brain using this technique as well. And then you can see large spaces around the blood vessel when you do a third type of imaging in the brain. And so this isn't just normal aging, there are actual signs of this on the MRI. And so what are our goals as a research consortium and what are our approach? Well, our goal is that the heart and the brain are special in the fact that they're both, it's called postmitotic, but that means that they no longer replicate. The neurons and cardiomyocytes are cells that after you're a child no longer continue to replicate. And so if they're damaged and if they die, at least right now, we're not able to induce them to proliferate and to regenerate. And so what we need to do is we need to diagnose early, we need to diagnose before damage is done, and we need to try and to solve problems before the tissue actually becomes defective. And so our approach is twofold. We're trying to develop techniques that don't per se diagnose cardiomyopathies or diagnose vascular dementia. We're trying to develop techniques that look for defects in perfusion of these organs and defects in the microvasculature. The other thing that we're trying to do is to understand why microvascular, whether we can treat microvascular defects and whether we can address these, but I don't have time to go into this part, so I'm just going to focus on how we're trying to do early diagnosis. So like I said, we're a European consortium that's funded by the European Union, and we have different clinical groups and other groups, including Cardiomyopathy UK, that are involved in trying to address this problem, both from clinical insight and from basic research. Now, what did we actually do? Well, we took patients with cognitive impairment, and we took patients with diastolic heart failure. Within diastolic heart failure, we had patients that had different severities, but we also had patients that had aortic stenosis. And so in their case, whereas people with diastolic heart failure A, B, and C were largely lifestyle, hypertension, and these types of defects, aortic stenosis get diastolic heart failure without any of the lifestyle effects. So we could compare what was going on there. And then what we then did was to do a brain MRI, a cardiac MRI, as well as do blood sampling on the patients with vascular dementia. We did the exact same tests on the patients with diastolic heart failure. And we also had a population of healthy age patients to look at what was normal function without either brain or diastolic dysfunction. And so what did we find? Well, when we looked at the cardiac MRIs, we could see that the patients with diastolic heart failure, whether it was due to hypertension or diabetes, or because they had heart valve disease, had decreased blood flow to their heart itself. So we could see that in the MRI, even in early stages of the disease, that they had decreased blood flow to the heart muscle itself. In the blood samples, what we were focusing on were these particles called extracellular vesicles. They're little membrane-bound particles that your cells give off that contain protein and genetic material like DNA and RNA from within the given cells. So your cells produce these particles all the time, and they sort of give a glimpse of what's happening within cells. And you can find them in your blood, you can purify them, and it can give you a bit of an insight to what's actually happening in the cells that gave off these particles. And so we collected these extracellular vesicles and looked at what the gene expression or the changes in the RNA in these were, and see if those can be markers of disease. So with the the bloodborne particles, we then do something that's called RNA sequencing. We look at every single one of the genes in those particles and look if they go up or down with disease or not. And so these are the ones that went up when we looked at patients that had diastolic heart failure as compared to patients at risk for it that didn't have it, and these are the ones that go down. And so we've found we've found many, but we've been following mainly up on one gene that we can find in the blood that correlates to the degree of, or the severity of disease progression. And so we're hoping that using this as a blood-based test will allow us to test whether people are, to stratify risk among patients and know which patients are going to fare worse and should be treated more aggressively. Now, in terms of cognitive function, we also put all these patients through a cognitive test. This is a test where there's a list of words and you have to recall words. This is a test where first you need to read these words out loud, then you need to say what color is here out loud, and then you time how long it takes you to do the third list where the color doesn't match the word. This is a trail maker test where you have to go from 1 to A to 2 to B and so forth. And so the measure of all three of these are brought together towards a total cognitive score. And so when we look at this, if we look at the most severe patients with diastolic heart failure, their cognitive function was actually as bad as the patients with vascular dementia. Now this, when we look at the patients with aortic stenosis, this wasn't the case. So it's not just heart function, but also vascular health that's important. Okay, so even, I know everybody here has, or most of the people here have problems with their heart function, but the main sort of take-home message that I wanted to say is that your vascular health is also important. And even if you have defects in your cognitive, in your heart function, your cognitive health matters on your vascular health. And then the last thing I wanted to mention in terms of results is that one of the groups that was the neurologists, they did some scanning of the brain of patients, looked at cognitive function, and then 2 years later did more cognitive tests. And what they found was that the lower the blood flow was initially, the more significant the cognitive decline was 2 years later. Okay. So what does this mean for patients? Now, the patients with heart failure did not have any brain damage on MRI, but their cognitive function was decreased. And depending on how severe their diastolic heart failure was, then they had worse brain blood flow. Okay, and so what does this mean? How can you help your vascular health? Well, it's a lot of the same advice that you've probably gotten everywhere. Your vascular health is about what you eat. It's about trying to keep up with exercise. And we had a talk, I know a lot of people with heart problems cannot do exercise, but we had a talk earlier today about talking to your physician about how much exercise you actually can do. This will not only help your heart function, but it will also help your cognitive health. People think about cognitive health as doing quizzes and puzzles and stuff like that. Your physical health of doing exercise or eating well is actually, we're figuring out, more and more important than doing puzzles and keeping up your cognition. And so vascular health is important for cognitive health. And so that's my last point. Oh, and take your hypertension medication and your cholesterol medication, because those also really affect your vascular health. And so with that, I would like to thank everyone for listening to me. And